And welcome back to Twitch. We're streaming live here for our meteorology segment. And what we're looking at here is nullschool.net's display of sea surface temperature anomaly. Yes. And I just wanted to briefly talk about sea surface temperature in that Earth's heat latency lies in the oceans. In other words, you can measure the atmosphere all day, and if you don't know the temperature of the Indian Ocean at 30 and 300 and 1,000 meters, you don't understand the planet's climate. Less than 1% of Earth's heat latency lies in the atmosphere, as air is very diffuse compared to water. Water has a massive latency of heat. In other words, it takes a lot of energy to heat up or cool down water, which is why sea surface temperature anomaly is probably a more important measure of climate than any atmospheric measurement. But in any case, I just wanted to make this point in that people don't seem to understand the first thing about atmospheric physics, and yet they want to try to convince you of things that they themselves do not understand. So anyway, we're going to rotate the whole planet here and look at sea surface temperature anomalies just from the equatorial view here, as we've got hot spots and cold spots. And also keep in mind, folks, sea surface temperature anomaly is only measuring the top meter of the ocean water. What's going on below that could be completely different. And let me just reiterate, Earth's heat latency lies in the water in the oceans, not in atmospheric measurements. Atmospheric measurements are caused by the heat and cold of the ocean. So you can see the Central Pacific looking cold in the eastern portion, hot in the western portion. The Arctic Ocean, anomalously cold. How about the Southern Ocean? Quite a variation there. And let's take a look at the normal stuff that we usually look at, starting out with the jet stream. So here are the jet streams of the eastern world. And the jet stream is probably the most significant. If you needed to know global weather patterns, the jet stream would probably be the best. This is the 250 hectopascal winds. And you can see them blowing backwards again here over the western Pacific and Indian Oceans. Here are the surface winds of the eastern portion of the planet, and some strong winds here continuing south of Australia as well as south of Kamchatka. And in the Aleutian Islands as well, you can see some strong winds up there. Let's rotate the planet to look at the western portion of Earth. There are the surface winds of the western part of the planet. Here are the jet streams. And the funky weather, the heat waves going on the east and west coast of the U.S. are entirely caused by the jet stream. And you can see some of the patterns causing it. We're getting hot air because of hot water in the Atlantic Ocean. And that's why it's so hot where we're located. We're located in eastern Pennsylvania. Lehigh Valley is where SMASH staff and I are located. Here's the NASA GOES lightning mapper. And I thought I already had that initialized. Let's look at the real-time lightning maps while that loads. So here's lightningmaps.org, and we do see some terrestrial lightning here around western Pennsylvania, it looks like. Just a couple errant lightning strikes there. Some transient lightning. Doesn't look like any major storms. And here's the NASA GOES lightning mapper. There could be some missing data there. I'm not exactly sure why it's freezing up. But let's move on and not worry about it. And some additional lightning showing up here. It looks like just north of Terre Haute, it looks like there's thunder rolling in. And lightningmaps.org gives you great real-time information. If you're hearing thunder, check it out, lightningmaps.org, powered by blitzaltung.org. Powerful low-pressure system here out in the Aleutian Islands, as well as low pressure all around Antarctica. You can see the whole southern portion of the map here, the South Geographic Polar region, totally dominated by low pressure. This is a strong one here in the northern Pacific. Let's advance this into tomorrow. Here's the GFS forecast. I'm sorry, that's the European forecast for pressure at tomorrow, 1 p.m. Eastern Time. And let me check the life of the stream here. Again, we are streaming live. Looks fine to me. Continuing on to tropical tidbits, we're showing you temperature anomaly now. This is about where things are now. And this is the GFS forecast for about 1 day from now. That's 12 Universal Time tomorrow on July 1st. Again, our red bubble sale will end by July 1st. You can find a link to that smAsho merch at smAshomash.com. Prices will go up and products may change with no warning. Anyway, a little bit of a relaxation and we're going to get a cold snap here. So there's the forecast through 1800 Universal Time on Friday. Places like Virginia will see like 15 degrees Celsius below normal temperatures, while the heat wave continues largely in the Pacific Northwest. Here's the weather.gov map showing excessive heat warnings and heat advisories in large portions of the country. The flooding warnings have subsided a bit here in the central part of the country. Have you heard about the disappearance of a 200 billion gallon lake on Antarctica? Yeah, it caused the ice sheet to lift up because water is very heavy. It's not just very good at retaining heat, folks. It's also very massive. And actually, little known fact, when Earth rotation speeds up, it's evidence of global cooling because Earth rotation can speed up as a result of less water in the oceans, in other words, deposited at the poles via snow and ice, or colder water. Since colder water takes up less space, less or colder water causes the Earth to rotate faster, the same way a ballerina spinning around rotates faster when she pulls in her arms. The Earth's equatorial bulge shrinks when the planet gets colder, and the planet's rotation speeds up. This is known from eclipse records for thousands of years. And frankly, anybody who's telling you that the Earth's rotation is speeding up because of magnetism is clueless, idiotic, and has no idea what they're talking about. Detailed observations of an ice shelf. Now, this happened in 2019. The paper just came out on June 23rd. And it's about the draining of an Antarctican ice lake. It's really not that big of a deal, as it's actually quite cold in Antarctica. But in any case, I guess this article is trying to make you very, very frightened about the melting of ice, something that happens every summer in Antarctica. Anyway, what happens is a crack opens up underneath the ice lake caused by meltwaters, which causes it to drain into the sea as ice shelves are over the ocean. And there you can see the lifting up caused by the less gravity after the ice lake drained. You can see these features here lifting up. That's the ice sheet responding to less mass on top of it. So there's an interesting story. This one is on, I think it's on SciTech Daily. Is it on SciTech Daily or phys.org? Let me just get to the bottom here. It's on SciTech Daily. So, sudden disappearance of giant Antarctic lake leaves massive crater, 200 billion gallons of water. GAN. It's just GAN. And here's another story about climate here. This one is about the decline of the dinosaurs. So let me read it. Let me start by reading a quote here. It became clear that there were two main factors. First, that overall climates were becoming cooler. Yes, that's right, cooler. And this made life harder for the dinosaurs, which likely relied on warm temperatures. By the way, humans also rely on warm temperatures. The colder it gets, the harder it is to farm and produce enough food to feed 8 billion people. Or however many billion people there are. Are we up to 8 billion people yet? I don't know. I think the planet's capable of supporting like 10 billion people. But in any case, turns out dinosaurs were in decline for millions of years before the final asteroid death blow. So I'm not going to really go into any depth about this. It's just apparently cold temperatures started declining their populations before the major asteroid or comet impact. So whatever it was They were already in decline. I'm just going to let the article scroll here, and you can see their extinction rate went up and their speciation rate went down at the same time, as you can see here. Can you say bolide? All right, I'm not going to go any more in depth into this. You draw your own conclusions about it. Perhaps read the article if you like. Feel free to pause the video. We'll be here when you get back. And let's get into more current weather data. So here's the U.S. Doppler radar map. And let me just check the life of the stream one more time here. Everything looks kosher. There's a U.S. Doppler. Here's a U.S. cloud layer. It's the 3.9 nanometer radiation map from the NASA GOES Interactive Weather Satellites suite. And it's pretty sweet, but not quite as sweet as the water vapor map, which gives you the most insight. So some massive moisture building here in the Gulf of Mexico. You can see all this rapid evaporation happening. And there you can also see it on the 3.9 nanometer radiation map, which shows you the cloud layer. Anyway, here's a recap. There's the U.S. Doppler radar map. Here's once again the cloud layer. And here's the water vapor, which should give you the most insight into what's going on. Thanks for tuning in to today's meteorology segment. I've been your host, Dan, a.k.a. smAsho, signing off from the Smash News Network, Least Busted. Name it News.